Welcome to day 27, Debugging and Optimization in Object-Oriented Programming. In this session, we will explore key techniques and best practices for debugging OOP code and optimizing its performance. Let's begin with debugging. Debugging is the process of identifying and fixing errors, commonly known as bugs, in your code. It ensures that the program behaves as expected and helps improve code quality and reliability. It's an essential skill for every programmer. In object-oriented programming, we encounter several types of bugs. These include null pointer exceptions, where we try to dereference a null reference, and incorrect use of inheritance or polymorphism. We also deal with memory leaks, where memory is allocated but not deallocated, and logic errors, where the algorithm does not work as intended. It's important to recognize these common bugs to fix them efficiently. Let's look at some common debugging techniques. First, we have print statements. This simple technique allows you to display variable values at different points in the program, helping you understand the flow of control. Another common technique is using breakpoints. By setting breakpoints in your IDE, you can pause execution and inspect the state of your program step by step. Next step through debugging allows you to go through your code line by line. This helps in tracking down errors in more complex sections. Additionally, unit testing is crucial. Writing unit tests for each part of your code ensures that components behave as expected and makes it easier to isolate and fix bugs. Memory management refers to how memory is allocated and deallocated during the execution of a program. Improper memory management can lead to crashes and memory leaks. In languages like Java and C Sharp, garbage collection handles memory management automatically. However, in languages like C++, programmers are responsible for manual memory management, which requires special attention. In C++, memory management is done manually. You use the new keyword to allocate memory and delete to free it. However, improper memory management can cause issues like memory leaks or dangling pointers, which occur when memory is freed and then accessed again. It's essential to handle memory allocation and deallocation carefully to avoid these problems. To help with memory management, C++ provides smart pointers. These include unique pointers, shared pointers, and weak pointers. Unique pointers take ownership of objects, shared pointers allow shared ownership, and weak pointers prevent circular references. Using smart pointers automatically handles memory deallocation, helping to prevent memory leaks. Optimization is about improving the performance and efficiency of your code. It's critical for handling large-scale applications and ensuring that your program runs smoothly. Optimizing your code involves reducing memory usage, improving processing speed, and maintaining clean, readable code. Let's explore some techniques for achieving this. One optimization technique is avoiding redundant object creation. Instead of creating new objects repeatedly, reuse them wherever possible. Another method is reducing method overhead. Frequent function calls can slow down your program, so consider inlining small functions to minimize this overhead. Next, caching and memoization are powerful optimization techniques. By storing the results of expensive computations, you can reuse them later without recalculating. Also, using efficient algorithms is key to optimizing your code. Choosing the right data structures and optimizing algorithm complexity can drastically improve performance. Now, let's look at an example. The first step in debugging is to understand the code thoroughly. Review the provided code carefully and identify where the bugs might be based on the symptoms you observe. Once you have located the problem, use debugging techniques like print statements or breakpoints to identify the exact issue. Once you have identified the bugs, the next step is optimization. After fixing the bugs, review the code to see if there are any redundant operations or inefficient data structures. Look for areas where you can improve performance or memory usage. Here are some best practices. Code reviews are one of the most effective ways to identify bugs early and suggest optimizations. Refactoring is another important practice. Regularly revising your code to improve its structure and efficiency. Finally, profiling tools like gproof or visual VM can help identify bottlenecks and optimize your code further. To conclude, debugging and optimization are key to writing efficient, reliable OOP code. Debugging helps identify and fix bugs, while optimization ensures that your code runs faster and uses resources more efficiently. As you work on real-world projects, practicing these techniques will help you become a more skilled programmer.